Okay, sorry if you saw a little bit of a blip there. I ran out of hard drive space as I was recording the last video, and I had to pick up right here. So I think the last thing we were mentioning was that we want to get the M2s together. Okay, so we could move this M2 with its accompanying VFI or VSR VF1 over there, or we could move this M2 over here. Now, if we do, let's think about this for a second. If we move this over there, that means both the M2s are going to be negative, and we don't really want that. So why don't we take this M2 and add it to both sides and bring it over here? That way the M2s will be positive, and everything will be else will be in terms of M2. So this M2 and its accompanying initial velocity of object 1 is going to come over there. And while we're at it, let's move our M1 over to that side. Okay, so we're going to add well, let's just write it. So this is going to be final velocity of object 1 times M2. And we're going to add this to the other side plus initial velocity of 1 times M2 equals, and we're going to subtract this from both sides. So I'm going to write this one first. Initial velocity of object 1 times M1. And now we're going to subtract this from both sides, minus the final velocity of object 1 times mass 1. Okay, all we did was we added and subtracted so we could get all of our 2's on one side and our mass 1's on the other side right there. Okay? Well, again, we want to solve for M2, so let's work on getting these separated out of here or extracted out. Well, now we can do that. We can factor out the M2's now. Pull that out front, and we're going to have our M2's combined into a single variable. M2, put that out front of final velocity of object 1 plus initial velocity of object 1 equals, and we could write this out the same way as well, but it might just be easier if we factor out the M1's as well. Mass 1 times initial velocity of 1 minus final velocity of 1. A little cleaner? Okay, only one more step, right? Because we're solving for M2. Let's simply divide by this expression right here. So that means that M2 is going to be equal to M1 times initial velocity of 1 minus a final velocity of ball 1. I'll cross it out. I'm going to divide it. Divided by this whole expression right here. V final 1 plus V initial 1. Okay? And great, there we go. Now we have an equation that is actually solving now for M2. Of course, we had the equation before, but the M2's were broken up. Here we've used algebra to combine them together into a single M2. So I'm going to take this, I'm going to draw it up here. That's not very good. I'm running out of space on my pad here. Okay. So we're going to say that M2 equals what? Now we can start plugging things in. M1, we just said that was going to be called M. All right. Times the initial velocity of object 1. We know that. That's what we call VO, V sub O. Minus the final velocity of object 1, which is, we said over here, minus negative 0.25 times VO. Okay? This is a parenthesis right here. I'm closing the other parenthesis. Okay, all this divided by the sum of the two velocities, V final of 1 plus V initial of 1. So that's, oops, negative 0.25 VO plus VO. Okay, now to clean this up a little bit, let's undo these, let's just kind of rearrange these subtractions right here. That's really like saying that M times VO plus 0.25 VO over VO minus 0.25 VO. All right. The way I'm going to do this is different from the way I saw some of you doing it, but those of you who got the right answer, obviously you were doing it correctly. Let's factor out. I'm going to factor out these VOs first. So we're just going to have numbers in the parentheses here. So this is going to equal M times VO, M times VO times, this would become 1 because we're factoring out these VOs here. 1 plus 0.25 divided by VO, because we can factor out the VO on the bottom here too, times 1 minus 0.25. Okay, so we factored out the VOs, and I did that first, so it becomes very clear, hey look, these VOs can go away. They simply simplify to 1. Okay, because they're all being multiplied there. So one last little final step. Let's simply find out what this fraction is equal to. Equals M times, what's 1 plus 0.25? Well, that's easy, duh. 1.25 over 1 minus 0.25, 0.75. Okay, and we can simplify that. That fraction can simplify if we divide each side, or divide top and bottom by 0.25. That really simplifies to 5 over 3 times m. Now you can actually make that into a decimal as well. That's perfectly fine. I think that would wind up being 1.67 m. That's 5/3. Okay, but this is our answer right here. The answer is in terms of m. The mass 2 is 5/3 as heavy as mass 1, which is why I drew this slightly larger up here. Now again, back to the error. If we didn't account for the fact that 1 was rebounding and had a negative velocity, plugging just 0.25 in over down here, well actually it'd be up at the top right here, plugging just regular 0.25 would give you an answer of 3 over 5. Well, it's actually not correct. So this was a typo. It should be 5 over 3. So if you got 5 over 3, you did it correctly, because 1 is rebounding and 2 is taking off in that original direction right there. So there you have it. That's our mass 2 for really just part A of number 5. I'll label this A right here, and some of you are thinking, oh my gosh, that's just part A. It is, but that was a hard part. Part B is going to be considerably easier. So I think I'm going to do part B in another video. So I will see you in that one, and take care.